All right, so welcome back to everyone. A very warm welcome to all of you, my dear students. A very warm welcome to all of you. Very good evening. Hello, Shisai. So, guys, in this session, first of all, I am Dr. Umashankar and I am your physics educator. You know me well. Now, let's begin with the session. So, guys, in the last session, we have been speaking about the vectors in Cartesian. Okay, and we have seen that how we can do the addition of two vectors that are given to us in the Cartesian form, and how from where this Cartesian form appears, and what is the Cartesian form, what is the significance of it, how we can operate into it. All these things we have seen in the previous session. So in this session, we'll be talking about one very important concept, and that is the concept of position and displacement vector. So I'll be starting with the concept of the position vector and displacement vector today. Okay. Okay. And this is going to be very useful in understanding of the physics. Okay. Now, what is the position vector? Now, what is the position vector and what is the need of it? Okay. So let's try to understand this, that what is the position vector and what is the need of it. So basically, see, position vector, okay, it is the vector which is used to know the exact position of something. It is used to know the exact position of something. Okay, and this is thing like very practical thing. Now please understand it. So vector is something which is having magnitude and direction. Now please understand this. So if you want to give the exact position of some quantity or some vector or something, you always need to take a reference. Okay, you always need to take the reference. Like for example, if some post is coming at your home, post, not the post that we get on Facebook or something, like the speed post, like courier, and that courier guy calls you. Okay, sir, I'm trying to reach to your home. Can you give me some landmark? Right? So, what is that landmark? Landmark is sort of a reference through which one can easily understand your position, right? One can easily understand your position. Like, for example, my home is very near to IIT Roorkee. Okay, so I say, like, please come on this number gate of IIT Roorkee, and from there takes a right turn. Then moves in a straight direction. Okay, then take the first left. Like this, we give the direction to someone now from some reference. Right. Now this is how the position vector comes into the picture in physics, and this is very important because this basically gives someone an idea about the position of any vector, that what is the position of a vector. Like for example, okay, and this reference can be taken from anywhere, but normally we take this reference from the origin. So let's suppose this is our origin. Okay, this is our origin. We know the coordinate of origin is 0 0. So origin is that reference point. Okay, and reference point could be anywhere. Okay, though in general we prefer to take it from the origin because that is quite a landmark in our physics. No, like when we see the coordinate system, we see that this intersection of all the coordinate axes is the origin, and normally we take the reference from this very point. Okay. Okay, now let's say that some vector is having the position of P. Okay, some vector is having the position of P. Okay, now you want to describe this point P. You want to describe this point P through a position vector. You want to represent the position of this point P from this reference. Okay, so obviously, whenever, again I'm repeating myself, whenever you are trying to give some position to something, this is always from some reference, always from a reference. Okay, and that reference is generally the origin. That reference is generally the origin. So this is, let's suppose, a point P is there, and you want to represent the position of this vector, position of this point through some vector. So the vector which will be describing the position of this point or any point for that matter will be known as the position vector. Okay. Okay. So position vector, what it is? It describes the position. It describes the position of any point. Okay. From some reference. From some reference. So see what you need to do here. So we need to, we need to connect, okay, the reference point to this, point. So from the reference, if you connect this directly, okay, if you connect this directly through the shortest route, that is what we call as the position vector, and this is normally given as r. Okay, position vector. So this is the general representation, that is r. So this r vector is the position vector. This r vector is the position vector of this point P, and this is used to describe the position of this particular point. Now, is that clear? Please answer me. Very, very important to understand it. Okay, you will be able to solve like very, very tricky question using this concept of kinematics. Okay. Okay, so now if I say, now please try to observe. If I say that the coordinate of this point is x and y, coordinate of this point is x and y. So now you see that this x and y has to be this. This is your x, right? And this has to be your y. This has to be your y. Now, can I describe this r vector as xi cap plus y j cap in Cartesian? Do you agree or not? Please answer me. So we know that the component with I, or the multiplier with the I, is nothing but the component of any vector in x direction, and the multiplier with the g is component of any vector with the y direction. So this is going to be x and y. Do you agree or not? Now, can I describe this position vector in this case as xi plus yj? Do you agree or not? Please answer me. Okay. Yes or no? Wonderful. Now, see any vector. Now, any vector. So this is the vector R vector, which is the position vector for this P point, which is the position vector for this point. Now, if I ask you that, please get me the magnitude of this vector. So you would say, sir, it is very, very easy. I can obviously get the magnitude, and the magnitude of this vector we know. Since it is in Cartesian, I can find the magnitude like this. Do you agree or not? Again, please answer me. We can find the magnitude of this vector like this. Yeah, yes or no? Yes, sir. Most certainly. Most certainly, this is the magnitude of it. Now, if I ask you, what is the direction of this vector? So the direction is going to be, we know that this is going to be r vector upon mod of r. Okay, mod of r. So see, from the coordinate of some point, if you have the coordinate of some point, you can find the position vector. Then you can have the magnitude of that position vector as well as the direction of this position vector. Okay, direction of this position vector. Now, if I say that someone is moving with a speed of 50 meters per second in the direction of position vector of P. Okay, if I code a man is walking, a man is walking at a speed of at a speed of 10 meter per second in the direction direction in the direction of position vector, in the direction of position vector of P, in the direction of some point position vector of P whose coordinate is x, y from the origin. So how will you be describing this vector? Can you tell me that? How will you be describing this vector? Can you answer me? Can you answer me? How will you be describing this vector? Can you please try to tell me that? Please answer me that. How will you be describing this vector? See, understanding of position vector will lead you to understand the displacement vector as well. Can you tell me that? Wonderful. Wonderful. So, sir, very simple it is, sir. Very simple. So, a man is walking at a speed of 10 meter per second. So, let's suppose this vector is to be described by v vector. So, the speed is 10. So, we know any vector is described by its magnitude and its direction. So, what is the magnitude of this vector? So, it is 10 meter per second because the speed is given 10 meter per second. So, obviously, the vector magnitude is 10 meter per second, and it is in the direction of the position vector of p. So we call the position vector of p as r vector. So now the direction of this position vector, so which will give the direction of some vector. So the unit vector gives the direction of some vector. The unit vector is going to give you the direction of that vector. So what happens? So we have this 10. We have this 10, and this r cap, it is going to be what? So r vector upon r vector upon r. So we can write it as 10. So here we have assumed that this is xi cap plus yj cap upon root over x square plus y square. Now using the position vector, again you can use to describe some direction, you can use to describe some other vector, right? I hope it is fine to everyone. Now what you do, just let's try to do it because this is very important. So find the, so R is the representation of position vector. So let's suppose we have few points R, B, C we have, so we want the position vectors of these D, okay, and RA cap, RB cap, RC cap, and RD cap. Okay, so let's suppose these points are given by the coordinates 2 cross 2. Okay, the coordinate of B is minus 2, 2. The coordinate of C is minus 2 and minus 2, and the coordinate of D is 2 and minus 2. Can you please try to solve this question? I'm very sure we can do it. Please go for it. Please go for it. So get me the position vector. Get me the position vector. Get me the unit vector in the direction of each of this position vector, and we have the coordinates of each of this point with us. Please go for it. Please go for it. I'm very sure we can do. Can you please try to give me that? So you do each of it, she said, and just give me a yes if I have done that. Then we can check. Otherwise, you will have to do a lot of writing in the chat, right? Just tell me when it is done. Just write done. Acha, you have done it. So let me do it. So now we have A, B, C, and D. So if I make them in the coordinate axes, so it will be, we can write x, y, minus x, minus y. So we know how to locate these points. So if I talk about A, so A is here 2 cross 2, 2 cross 2. So can I say that, so first let me locate all these points. So B is going to be minus 2 and 2. So B will be somewhere here, minus 2 and 2. Then we have C. C is minus 2 and minus 2, minus 2 and minus 2. And D is going to be 2 minus 2. D is going to be 2 minus 2, right? Now, if I ask you what is the position vector of A, so this is your origin point. So this is going to be the position vector of A. let's call it RA vector. So now this RA vector, we can write what is this RA vector? So I can write it in Cartesian, and if I write it in Cartesian, it will become 2 I cap plus 2 j cap. Okay, so just by seeing this component, just by seeing the component, we can write. Now, similarly, for B, so for RB, sir, this is going to be RB. The position vector is the vector you get by joining the origin to the coordinate of that point or to that point directly. Okay, so this is going to be your RB vector. And what is going to be your RB vector? So it is going to be minus 2 of I cap, okay, plus 2 of j cap, okay, minus 2 of I cap, that is its coordinate in x, then 2 of j cap, that is its coordinate in y, okay. Now if we have this, if we join this to C, so this is the position vector of C, this is the position vector of C. So now if we do with the position vector of C, it will become minus 2 of I cap, then minus 2 of j cap. So minus 2 of I cap and minus 2 of j cap. Now what is going to be the vector D? So the vector D is going to be, so what is vector D? So if we join this with this origin, this is going to be the vector D. No problem, she said. She said afterwards we'll be understanding the displacement vector. So do watch the recording. If you cannot watch the live session, don't there's nothing to worry about. But please do watch the session because this is just the beginning. I'll be coming to the displacement vector afterwards, right? Which is a very important concept. Okay, beta. So please do that. Okay. Now coming to this D vector. So if I say this D vector, so it will become 2 of I cap minus 2 of j cap. Okay. So just by seeing the coordinate of any point, you can get the position vector of something. Now we can find this RA cap also. So what is going to be the RA cap? So it is going to be RA vector upon mod of RA vector. Okay, so this is going to be 2I plus 2j, okay, divided by mod of it. So it is root over 2 square plus 2 square, right? So this is going to be 2I plus 2j, 2I plus 2j upon root over 8, root over 8. Now similarly, what is going to be this RB vector? So the RB unit vector in the direction of RB, so it is going to be the vector that is minus 2 of I cap plus 2 of j cap divided by root over. So minus 2 square plus 2 square, it is again going to be 8. No problem at all. So now moving towards the unit vector in C direction. So unit vector in C direction, it is going to be minus 2 of I cap minus 2 of j cap upon root over 8 minus 2 and minus 2 whole of a square. So it is going to be root over 8. Then we have this D vector. So now what is the unit vector in the direction of D? So it is going to be 2 of I cap minus 2 of j cap divided by again the magnitude of this RD vector. So it is going to be root over 8. This is going to be again root over 8. So I hope it is fine to everyone, right? Now we learned about the position vector. We learned about the unit vector in direction of some position vector. Let's do one more question for more, understanding. So let's say the coordinate of a point, the coordinate of a point is 1 1. Okay, now you need to find what? So we need to find is position vector, is position vector. What we need to find, sir? We need to find is position vector. Okay, let's call it R vector. Okay, the second point is that what is the angle made by r vector with positive x-axis and the volume of the cone. Now this third part may interest you. Generated when the line segment so it is very simple only, but sometimes what happens that with such language students are getting confused, right? With such language sometimes we get confused. So volume of the cone generated when the line segment represents r vector rotates about positive x-axis when one end is fixed at origin. When one end is fixed at origin. Okay, now let's try this one. I'm very sure we can do it. Please go for it, beta. Please go for it. I'm very, very sure that we can do it. Please try to do that. Please try to do that. Please try to do that, beta. Very, very simple question. You have to think how we can do it. Now, what does this question say? So it says that the coordinate of a point is 1, comma 1. Find its position vector, angle made by the position vector with x-axis, and the volume of the cone generated when the line segment representing r vector rotates about x-axis. One end is fixed at origin. Okay, so how we can do it? How we are going to do it? So see. Let me try it. So let's suppose this is x, this is y, this is minus of x, this is minus of y direction. Now it says that the coordinate of a point is 1 is to 1. Okay, so let's suppose this point be P and its coordinate is 1 is to 1 and its coordinate is 1 is to 1. So we need to find firstly the position vector. So how we are going to get the position vector? So we can join it like this. So this is going to be the position vector. Okay, now this position vector is going to become I plus j, right? Because the component in x and y direction is this. Okay, now this is your position vector. Now the angle of this position vector with positive x-axis. So if you are saying this, so this let it be theta. So what is this angle? So angle is tan theta. We know it is equal to ay upon ax. And what is ay and ax? So any vector, for any vector, we can say that this angle that it is making with the coordinate axis or x-axis is going to be what? It is going to be the ratio of the y component to the x component. So tan theta is going to become ry by rx. Okay, it is going to become ry by rx. So tan theta will be, so ry is 1, rx is 1. Okay, so from here we can write theta is equal to 45 degree. So when both perpendicular and base are unity, we know obviously that theta is going to become 45 degrees. Now, this third part might have interested you most. Now let's understand the question. So it says the volume of cone generated when the line segment representing the r vector rotates about x-axis, one end is fixed at the origin. So what happened here? What happened here? So we have one end, this is one end that is fixed about the origin, and you have it rotated about the x-axis. Now do you feel when this vector is going to get rotated about the x-axis, we are going to get a cone like this. Please think of it. Okay, this vector is going to rotate like about the x-axis. So this is going to happen this way, this. So if this is x-axis, so this line is here. Now this is rotated about the x-axis. Now if you think, you are going to get the cone, you are going to get the cone. Now, so how we can find the volume? So what is the volume of the cone in general? What is the volume of cone in general? So volume, sir, we know it is pi by 3 r square h. So this is the volume of the cone, right? Okay. We must all know this, and I'm very sure that we must already have knowing this. Okay. We must already be knowing it. So now we can write that the volume is pi by 3 r square h. Now what is going to be the radius? So the radius is going to become 1. This is 1 only, na? The coordinate in this. So this is 1. And what is the height? What is the height? So this has to be the height. This is also 1, isn't it? This is also 1. This is also 1. So can we write volume is pi by 3? Okay, and if these are given in meters, so nothing is given, I can write unit cube. Okay, unit cube, that means if it is in centimeter, it will become centimeter cube. If it is meter, it would have become meter cube. If it is millimeter, it would have become millimeter cube. I hope it is fine to everyone, right? I hope this is fine to everyone. Now same way we can interpret this thing in 3 dimension also. In the same way, we can see this thing in 3 dimension also. So see, in Cartesian coordinates, it is very, very easy to switch between the 2 dimension and 3 dimension. The same context, the same concept, the same line of understanding, the same approach we can apply in both 2 dimension and 3 dimension. So normally in Cartesian, what happens? We are establishing some concept. We are establishing a concept in 2D, and now the same concept with nothing change we are using in 3 dimension. Right? Okay. Now see what is going to happen. So if I see this the thing in 3 dimension, now in 3D what is going to happen? So in 3D, let's suppose we are having the coordinate axis, the standard coordinate axis. So we know this is going to be x, this is going to be y, and this is going to be z. Okay, this is going to be x, y, and z. And now let's suppose there is some position vector. Okay, so there is some position vector. There is some point. So see, you have to see this in 3 dimension, right? You have to see this in 3 dimension. Now, if some vector is here, if some vector is, let's suppose, here. Now imagine this in 3D. So it can have the coordinate. So it is having the coordinate in all 3 axes. Let's suppose x, y, and z. So what is going to be? Just try to imagine in 3D. Okay, try to imagine in 3D. Like for example, I always quote this, that whichever room you are sitting, you just focus at the corner of it. You just try to look at the corner. If you see the corner, you are definitely going to see that 3 direction going out from that particular corner, isn't it? Yes or no? Yes, sir. Now just try to imagine that there is a some point which is away in all the 3 directions from that particular corner. You can consider it as origin. So this is going to be, let's suppose, x, y, and z. Okay. Now what is going to be the position vector? So if we connect this with r vector, this is going to be the position vector here, and in the same way, it is going to become x I cap, y j cap, and z k cap. X I cap, y j cap, and z k cap. So what is going to be the magnitude of it? So it is going to be x square plus y square. It is going to be x square plus y square plus z square. I hope it is fine to everyone. Right? Yeah? Please answer me. Is it fine to everyone? Yes or no? Agreed? And if you want to find the unit vector, if you want to find the unit vector in that direction, what you are going to do? So we can write r cap is equal to r vector upon mod of r. So this is about the position vector. Very, very simple. Very, very simple. Okay. Okay. Now let's come to the uh, uh, let's come to the displacement vector and see the unit vector application, the very, very important application of this position vector you are going to see in finding out the displacement vector. So displacement is a very, very widely used physical quantity. Okay, so from the word of displacement we come up with this word of displacement vector. And see, it is very simple. I'll just tell you. So let's suppose, okay, see, displacement vector. Okay, displacement vector. Now, please understand this. So let's suppose we are having our two-axis system. So why we are having the two-axis system? So see, screen is two-dimensional. Your copy is two-dimensional. So normally this is the way that is usually followed. That's the we understand something in two dimension, and the same concept then we apply into the three dimension, right? Now this is the displacement vector. This is the displacement vector. So let's suppose we are having 2 points. We are having 2 points. Let's say one point is A and one point is B somewhere here. One point is A, one point is B. Okay, one point is B. Now, sir, what is going to be? What is going to be the displacement vector? Okay, so what is displacement in general? What is displacement in general? So if someone has moved from some position to another position, the shortest distance between the initial position and the final position is what you call as the displacement, isn't it? Do we or don't we? Do we or don't we? If we have, let's suppose, if we have 2 points, okay, if we have 2 points, if we have two positions, and if we have two positions, so when we have two positions, when we have this two positions, guys, from the initial position to the final position, if you want to know the displacement, it is going to be the shortest distance from initial to final point. Now the same way this, that is the displacement vector. So what is the displacement vector, beta? Displacement vector is nothing but the vector joining the initial position and the final position. Okay, so we call this, so if between A and B we want to see the displacement vector, it is normally denoted as AB vector. AB vector. So from initial position of A to the final position of B. Okay. From initial position of A to final position of B, what is going to be the displacement vector? It is that vector which is connecting this initial point to the final point. It is the vector which connects the initial point to the final point. Now, how we are going to get it? Now, please understand, it's very, very simple. We have learned all these things, so it is not going to be very difficult. Now, if I join a vector OA, okay, so it is, let's call it R1 vector. So, do you realize that R1 is the position vector of A, point A? R1 vector describes the position of point A. That means it is the position vector of point A. And I also think that you believe that this is, now please observe, now this is the position vector of this B. This is the position vector of this B. Okay, this is the position vector of this B. Do you agree or not? Definitely, sir, we agree. Now, if you see this carefully, see, that is why, see, again, I'm going to give you this. So, I believe that the law of triangle of a vector is a very, very important law, my dear. Law of triangle of vector is a very, very important law. Why, sir, it is very, very important law? Because it is used in so many concepts that there is no question of it. Now, please understand this. So, here, if you see, OA, so let's call it AB vector here. Okay. Now, if I apply the law of addition of vector through the triangle law, can I say that R1 vector plus AB vector, it has to be equal to R2 vector? Arey, how come, sir? How come? Arey, please understand this. So this seems to be a triangle. Now, if two vectors, remember, if two vectors are given by the magnitude and direction by two sides of the triangle, the third side of the triangle will present the resultant of it, okay, when its order is opposite, right? Right, Sandra, wonderful. Okay, so from here, can we write this AB vector as R2 vector minus R1 vector? And what is the R2 vector, sir? R2 vector is the position vector of B and R1 vector is position vector of A. Now, what does that mean? So, if you want to find the displacement vector between two positions, you need to subtract. See, very, very simple. You need to subtract the position vector of the final position with you need to subtract the position vector of initial position with the position vector of final position. That's all. Very, very simple. If you want to get the displacement vector between 2 points, you need to subtract the position vector of the final point with the position vector of the initial point, right? So let's do it quickly. Now please understand it. So it is written like OB. See, what is the way? Now see, it will directly be printed in your mind this way, I think. So when it is written OB, so we know that the position vector is something which is taken from the origin or from the reference. So see, simply we can write it like this: OB vector minus OA vector. Are you getting my point? OB vector minus OA vector. Understood? Now, for example, if some vector is written like PQ, let's suppose you need to find the displacement vector between 2 points P and Q. So how you are going to write it? So how you are going to write it? So you are going to write it. See, final point will come first, initial point will come second. So OQ is what? It is the position vector of Q. You can write it as R2 vector, R1 vector. Similarly, if you want to find XY vector, so what it is going to be? It is going to be the vector OY minus vector OX. Okay, I think this you got this, no? If it is written like QP, vector QP, what is the displacement vector between Q and P? So you can write this as the position vector of the final point minus position vector of the initial point. So just by the subtractions, this is why position vector are so useful. This is why the position vector are so useful. Okay, so why the position vector is so useful, my dear? So the position vector is very useful because it helps you getting the displacement vector. Okay, and this is going to be further of high use, right? In physics, displacement vector is very, very useful. Now let's suppose we are having 2 points. So let's come down and make some formula out of it. Although I don't think that is required even, but still we can do that. So we have two axes. Let's suppose x and y, the general axis, and we are having, let's suppose, a point A and a point B. Okay. Now this is having, see, we have to be quick also in the examination. Now once we understood some concept, we can be quick enough. So x2, y2, z2. So let's not take the z right now. Okay. Otherwise you won't get the feel of it. So x2, y2. Okay. Now if I want the AB vector, if I want the displacement vector in the direction of AB or displacement vector between AB, see, can I directly write, sir, OB vector, that is the position vector of B point minus OA vector, that is the position vector of A point, and simply what we can do. So what is this OB vector? So we just have understood to write the what, sir, we have understood to write the position vector of some point. So basically it is written like this: x coordinate I plus y coordinate j minus OA vector. So it is going to be x1 I plus y1 of j. Okay, y1 of j. Now what is this position vector is going to become? What is this position vector is going to become? So can you write, sir, AB vector? AB vector is equal to, so see, we learned the addition and subtraction in Cartesian. So how do we add and subtract in Cartesian format? So we simply have to add the I terms, we simply have to add or subtract j terms, and we simply have to add or subtract k terms. So the terms with the same unit vectors can be added or subtracted. So can we simply write x2 minus x1 of I plus y2 minus y1 of j, right? So this is going to be the unit vector. And if I ask you that what is going to be, so see, there is no need of memorizing this formula. I never memorized this formula. So it seems to come out to be a formula that we have seen in the 10th or something, the displacement formula, if you remember. If you don't remember, that's okay also. So what is going to be the magnitude of this vector? What is going to be the magnitude of this vector? So AB vector we just came to know. Sir, AB vector is x2 minus x1. Okay, so right away you can also do na. Okay, see, very simple to memorize as well na. The difference of x coordinate of final vector and final position and initial position, the difference of y coordinates of final position and initial position with I and j, respectively. Okay, okay, and this is going to be the vector. So if I ask you what is going to be the magnitude of AB, so you are going to say, sir, x2 minus x1 whole of a square plus y2 minus y1 whole of a square, y2 minus y1 whole of a square. So this is something coming like the displacement formula we seen in the 10th class, right? Distance formula, sorry, not displacement formula, but the distance formula. Now, if you have been asked to find the unit vector in this direction, if you are asked to find the unit vector in this direction, so what you are going to say? Sir, obviously the unit vector in some direction is the vector divided by its magnitude. So if we are asked to find the unit vector in some direction, if we are asked to find the unit vector in some direction, also we will be able to do that. Right? Is it fine to everyone? Please answer me, the live students. Sondriam, Shishai, if any other student is live, also please answer me. What do you think? What do you think, Bilal? Please tell me. What do you think? Right? Very easy. Okay. Okay, now let's try one question. I want to ask you this question. Let me frame this. So, if I ask you one question, and this is going to give you some understanding also. So, which of the following is independent? Which of the following is, let's say, is independent? Which of the following is independent of choice of, which of the following is independent of choice of origin? Okay, which one of the following is independent of the choice of the origin? So let's suppose we are having a position vector, then we are having displacement vector, then we are having both of the above, and we are having none of the above. None of the above. So can the live students tell me what is going to be the answer to it? Can you please tell me what is going to be the answer to it? Please tell me, guys, what is going to be the answer to that? Please tell me, what is going to be the answer of it? Any answer? So, which of the following is independent of choice of origin? So, can we say position vector is independent of choice of origin? Absolutely not, sir. Please understand this. So, let's suppose we are having a coordinate xy, and let's suppose we are having a point A. Okay. Now, if I change the origin, so if this is your origin, if this is your origin, so this is your position vector. Let's call it R1 vector. Okay, now if I change the origin, if let's take the origin here, if I change the origin, the position vector is going to get changed. Yes, sir, obviously it is going to get changed. Okay, I can see the x, y, and z coordinate is changing. So now we can see clearly the position vector depends upon the choice of origin. Now what about the displacement vector? Let's suppose we are having a point B here, we are having a point B here. So this is your R2 vector. This is your R2 vector. If you see here, and this is, let's suppose, your R2 vector, if you are going to see here. So wherever is the origin, the displacement vector, which is described by this A and B, is it going to change? What do you feel? Wherever you take the origin, this AB is not going to change. So the displacement vector is independent of the choice of reference where wherever you are taking the reference of some reference of the origin. A big thing, na? Okay. The displacement vector, please remember, the displacement vector is independent of the choice of the origin. That means it is independent of the choice of the, it is independent of the choice of the reference. It is independent of the choice of the reference. I hope it is clear to everyone, right? I am hoping that this is clear to everyone. Right? Please answer me yes or no. Wonderful, Beta. Wonderful. I hope you are getting that thing. So let's try one question then again. Okay. So now let's suppose a particle, a particle moves from, a particle moves from -1 to 2 to 2, 3. Particle moves from -1 to 2 and 3. Find the, find the displacement vector. Okay. So basically a particle moved from one position to another. Now you need to find the displacement vector. Okay, you need to find the displacement vector. So see, this question you can do by the basics. Okay, law of parallelogram also. There is nothing like that you can't do from that. But the best way to solve this kind of a question is going through the displacement vector. Right? Please try it. Please try it and give me something. Find the displacement vector. Please get me the displacement vector here. I'm very sure we can do it. I'm very sure we can do it. Please go for it. Please go for it. Very, very simple. No? Even without making the diagram, you can do it. Even without making the diagram, you can do it. Right? Right? I mean, very, very simple. Isn't it? Please give me something. Please give me something, Mita. Any answer? So let us say we are having the displacement here. So x, y, minus x, minus y. So although it is not very necessary to draw the figure in these kind of cases, because see, you can simply do this thing now. So let's suppose this point is P, this point is Q. So displacement vector PQ is OQ vector. See, without giving any stress to your brain, you can do OQ vector minus OP vector. So OQ vector, that is the position vector. So it is going to be 2I plus 3J. Okay, minus OP vector. So it is going to be minus I plus 2J, minus I plus 2J. So if you open up the bracket, interact the I thing with I, the J thing with J. So it is going to be 3I plus J. So right away you can do that. Right away you can do. Or you can do this way if you want to visualize this also. So P point is somewhere here at the coordinate of minus 1 and 2, minus 1 and 2. And Q point must be somewhere here at the coordinates of 2 and 3. So this is going to be that position vector. Na? This is going to be that position vector. Now this is going to be, let's suppose, your R1 vector. R1 vector, this is your PQ vector, and this is going to be your R2 vector. So what is the PQ vector? It is R2 vector minus R1 vector. RQ vector minus R1 vector. Is that clear? Please answer me. Right? Okay, so if at all you need to find the magnitude of it, I'm very sure you can do. If at all you are supposed to find the unit vector in this direction, I'm very sure that you can do. Right? Shall we move ahead? Yes or no? The live students can tell me. Okay, wonderful. Now let's try one more question. So let's suppose a particle whose speed is 50 meter per second. A particle whose speed is 50 meter per second moves along the line from A to N1 and B 9 and 25. Okay. Now what we need to do, we need to find its velocity. We need to find its velocity vector. Okay. In the form, velocity vector in the form of AI vector, AI vector plus BJ vector. Okay. Can you please try it? Can you please try it? Very, very simple. I'll give you some options to this also. Let's do it quickly. From 5:30, we are having the biology session by Harsha on the channel. Okay, so let's do this question, and from this point we can continue in the next session. So in the next, so almost the position vector, displacement vector is about to get finished, and in the next session we can come up with the products of vector, that is multiplication of vector. So we understand that there are two kinds of multiplication in vector. One is cross product and one is dot product. It's scalar product and vector product. So we are going to talk about them. Okay, what are they? What is their use? How you can use them in physics? So all this thing we'll be talking in the next session. Okay, now please try this one. Let's try this one. Let's try this one. Please go for it. I'm very sure we can do it. Please go for it. Very, very simple question. Please try to solve this one. So now it says a particle whose speed is 50 meter per second moves along the line from A vector, A point to B point. Find its velocity vector in the form of AI plus BJ. Now let's try to understand this question. Now it says, there are 2 points having the coordinate of A and having the coordinate of B. So it is 9 and 25. So it must be somewhere here. Okay, 9 and 25. Okay, just randomly I am taking. So it is 2 and 1. It is going to be 9 and 25. Now don't tell me that 2 it must be more towards positive x, less towards y. Okay, you understand this now. Okay. Now it says find velocity vector. So the particle whose speed is given moves along the line from A and B. So moves along a line from A and B. That means this is the direction of this vector. Okay. And this velocity vector, so any vector is given by the magnitude of it and the direction of it. Now, do you realize that it is since it is moving in the direction of this line joining A and B, since it is moving in the direction in which the line joining A and B, what can we say? We can say that the velocity vector is nothing but the magnitude of velocity and AB cap. That is the unit vector in the direction of AB, because we understand that the unit vector gives the direction in some, gives direction in some, give the direction. Okay. So what can we do? So V vector is going to be, what is the magnitude of V? It is going to be 50. What is going to be the AB cap? So AB cap, now see, we are going to do it right away. So AB cap is going to be the unit vector. So what is going to be the vector? So 9 minus 2, that is 7. See, x2 minus x1, very, very simple, right away. We don't have this much time in the examination. 25 minus 1, that is 24. Okay, j cap, 24 j cap. And what is going to be the magnitude? So it is going to be 7 square plus 24 square. So what we are getting, sir? So 7 square plus 24 square is 25, right? Okay. So V vector is going to be 50 into 7 I cap plus 24 j cap upon root over 625. So you can do it. So see, this appears in many questions. So you must be, when you are practicing, you will come to know that the 7 square plus 24 square is 25. Okay, when we practice question, these things happen by themselves. So what is going to happen? So 25 50, that is 2 7 I cap plus 24 j cap, 24 j cap. Right. So what is this going to be? It is going to be this one. Okay, or it could have been written as 14 plus 48 of j cap. Understood, Vida? Understood? So guys, in this session, we have understood about the position vector. In this session, we have understood about the displacement vector. So from 5:30, biology class is going to start. So I'll be stopping this session now. And from this point onwards, I'll be picking up in the next session, in which we'll be also talking about the multiplication in the vectors, that is the dot and the cross product. Okay. So with this, thank you very much. Have a nice day. And please don't forget to subscribe the channel.